Good morning. I am thinking about starting a short series, like a fireside chat, but it'll be a little bit different. I will tell stories, analogies to explain some interesting ideas, philosophical ideas mixed with science, observations, experience, essentially to bring understanding and also some intrigue. I love explaining complicated things in a way that A shows how it works, and B maybe opens a side that nobody's thought about. Well, somebody's thought about it, but probably hasn't been explained very often. So, if you like this format, if you feel there could be another way, please drop me a note. If you like it, do a like. If there are enough people who are interested, I will continue. I'll bring out various topics. And yeah, subscribe and I will continue. So I hope you enjoyed today's topic. I'm going to try the format of the whiteboard. And here goes. I'm going to discuss humidity, the effect of humidity on the coronavirus, and what relative humidity, absolute humidity, things like that mean. But hopefully in a way that everybody understands and enjoys. It's good to learn something. What I'm going to talk about now is respiratory viruses. So if we look at time, so let's say this is time as it ticks along. So this is, say, January. This is, say, July. And this is, say, the end of the year. Okay, so as we all know, the time that we really get sick from flus and viruses tends to correspond with the winter season. So this is summer over here, summer. Let me make summer yellow, sunny. So that's the summer. And let me make the winter a cold period. This is the cold period here, and it usually extends quite far across here. And so between summer and winter, of course, are the changing seasons. Okay, so if we look at when we are sick, it tends to be dominated with this period here. Then we hit the spring, we get a lot of allergies. But in terms of colds and flu, there's a complete decrease. There's some people who get a summer cold, but in general, there's a decrease. And then the fall comes, and then we start maybe a little bit of an uptick. But certainly the first really cold winter, and everybody's sneezing and feeling unwell, and then we hit our flu season. So, high in the winter, or predominant in the winter. Let me see if I can find a pretty color for us here. We'll go magenta. So this is the period over here, and over here, where there's really a predominance of respiratory or flu cold symptoms. And respiratory means they affect your mucus system, so you could be sneezing, you could be blowing your nose, you could be coughing, you could have fever, but it's all associated with the wet system. It's not a stomach ache, it's a congestive problem. Okay, so we are all familiar with this, and we get our flu shot in the fall or in the late summer to try and prevent the onset of these diseases. Okay, that's extremely obvious stuff right there. So that is what we observe, that is what we experience. So the question is, these events, this very simple thing that there's a lot here and there's a lot here and not much here, what causes that? Why does it follow the season? What is it about winter that makes us sick? Is it that the bugs like the cold and hate the heat? That's a possibility. Is our behavior somehow affected? We don't really often know, but there's a lot of evidence. So let's look at some of the evidence. First of all, one thing that I would say is that in terms of how we touch each other, kiss our kids, shake hands with people at work, drink coffee, touch the banisters, go shopping, I would say in general, remember this is generalization, most people shake hands all year. Most people talk all year. Most people hug all year. Husbands kiss wives and kiss their kids all year. We walk up and down stairs and touch banisters all year. So if you averaged out human behavior, it wouldn't be a huge difference in the seasons. Certainly not one where you'd go, wow, we never do that in the winter, we always do that in the summer. Skiing? Absolutely. Skiing, so let's look at skiing. Skiing seems to follow the same curve as flu viruses, the ski season. So there's correlation. Wow, this is really exciting. There's correlation between skiing and the flu season. Wow, correlation, does that mean causation? Does that mean that causing causes? Strange. Does skiing cause us to get sick? The answer is no, of course not. That would be ridiculous. Besides, not everybody who gets sick goes skiing. So, this is the first very important thing to remember. Just because something correlates, ski season correlates with the flu season, approximately, doesn't mean that the one causes the other. Causation and correlation are not the same thing. However, what we can say is that if there is no correlation, then there's probably no causation either. So I would say that because there is no correlation, this horizontal line of human touch, with the change in the infection rate and our experience of getting sick with the seasonality, there probably is not a big link between viruses, which are the flu viruses, cold viruses, and our touching habits. It just doesn't seem to fit. Where there is correlation, well, there also has to be some logic, because correlation does not mean causation. So there really is a challenge in science always between first of all, finding correlation. Find correlation. Without correlation, we're completely at a non-starter. Something doesn't match something else, probably not related. Okay. And if it does match the behavior, it doesn't automatically imply that it causes that. Skiing does not cause viruses. So these are very, very important terms. So we have seen, and I hope you're still with me, we have seen that there is very little correlation between touching and our behavioral habits in terms of transferring. We rub our eyes in the summer and the winter. We rub our brow when it's sweaty. In fact, we probably touch our face more in the summer than we do in the winter. So if I were to draw a curve of touching our faces, let's make that a grey curve, I would probably say the curve even looks a little bit like that. We'd probably touch our faces a little bit more in the summer because we may be wiping the sweat from our brow or the humidity. Anyway, that's not a big deal, but there certainly is very little correlation. So I've gone through all the various ideas of what correlates, read a lot, researched it, blah, blah, blah. And there are a few things that correlate quite well. So let's quickly have a look at some of those. Let me see if I can find another color. I'm going to use this greeny color over here. Okay, so what does correlate quite well is temperature. So let's say how cold it is. So how cold. So if it's very cold, brr, winter is very cold compared to summer, and then it gets warmer, and it's not very cold here, and then it gets cold. Wow, tremendous correlation between warm and cold season. Could it possibly be a linkage that viruses or us getting sick has a lot to do with being cold and being warm? Well, probably does. But we can add another simple fact. We are, in our modern world, our internal temperature, so how cold we get, and the clothes we wear, our temperature that we experience is probably quite uniform. I wouldn't say it's exactly. There is some correlation. This graph is getting really messy, so let me remove some of these curves right now. Okay, so on and on I go. The next and the most important correlation that I want to get to. Remember, I'm leading you to my conclusion. Haha. Okay, but let's see where we go with this. So I'm going to take a nice bright green. There is a very interesting correlation, and that is humidity. And not normal humidity. We're not talking about relative humidity, talking about absolute humidity. How much humidity, water vapor, moisture is there in the air in the summer when the temperatures are high? And by the way, there's an interesting scientific fact. When the air temperature is high, the air can hold more water vapor. So the humidity, the absolute humidity in summer, just by virtue of the higher temperatures, is higher. When it's cold, the air can't really keep moisture, and the absolute humidity drops. So just for now, take it that absolute humidity has an incredible correlation to airborne viruses, to colds and flus. There is very, very good correlation to absolute humidity. So we have two very good correlations, temperature and absolute humidity. So the question is it a bit of both? Is it possible that the flu viruses, that colds are related to temperature and absolute humidity? Well, the correlation is excellent, just as skiing is, but the likelihood of it being temperature and humidity related is scientifically more probable. And so in the next episode, if I can call it that, I will give you an indication of why temperature and humidity are probably the reasons, are the cause, not just the correlation, the cause of seasonality of flu viruses. And that explanation will be eye-opening when it comes to thinking about how we are going to combat the coronavirus, what we can expect to see going forward. If the cause and the correlation are related to humidity and temperature, it gets really interesting and has profound impact on what we do next, what we can do to keep ourselves safer, and what we can predict may happen in the future. Causal and correlation are the most critical tools for scientists to use to begin exploring solutions. And unfortunately, correlation does not equate to causation. It's a tough and fun thing to discuss. Okay, that's all for now. If you like this type of discussion, if you want to see me do more, if you have some recommendations, give me a like, send me a message please, and subscribe to this channel. If I get a nice response, I will continue. Take care everybody. Bye-bye.